Hi, welcome back to the interview set. I just wanted to
Take the time to explain to you an interesting concept that you'll be seeing a lot of here at the first LEGO League Provincial British Columbia Championships, which is the concept of steering, right? So I have a few models here that I've designed. This one actually is this is a real LEGO model from 1993 or something. But this is a really good demonstration of rack and pinion steering. If you look closely here, you can see that there's a pinion, the little teeny tiny gear, and then there's a rack, which is the long straight gear that it goes across. That's how your car works, probably. Most of them do, right? So there's that, and that's pretty simple. It gets more complicated though. It gets insanely complicated. So this one has parallel steering, and this one over here has Ackermann steering, which is what some race cars use. And basically what this does is the geometry is such that the wheel on the inside of the turn will turn more than the wheel on the outside of the turn, right? You can't really see it quite there, but trust me, it's important to have that in your design for a car at least, is the Ackermann thing. Also notice that there's no gears involved with this one, right? So that's Ackermann geometry. Now, both of these are actually pretty useless to talk about because most of the robots here are probably not going to use these steering systems. They're useful for cars, but not for robots like these because we're maneuvering in very, very tight spaces on these fields. So I brought another model, this is called the differential drive. And basically what you have here is you've got two wheels, and each wheel has its own motor. Or at least I don't have motors on this model. But the way that it works is one motor for this, you can go forward or backward. One motor for the other one, forward or backward. And in doing that, you can move your whole robot forward or backward or turn them around whichever way. Notice also you need 3 points of contact to not fall over. So I have a caster wheel on the back, which just rotates whatever way I want. That's like a grocery store cart wheel. This method of steering, like I said, is really useful. You're going to see a lot of this. It's not the only one. It's not the be-all, end-all best steering method. But it is very useful for a number of reasons. It can maneuver in tight spaces, and you can have actually two servo motors pushing the robot forward at all times, rather than just one, which is what you would have to do if you have this kind of steering, because you have one motor for the rack and pinion and then one motor to actually push the robot forward. So it's these kinds of things that have to be thought about when designing a robot for a competition like this. What kind of steering should you use? Because I've seen some really crazy steering solutions in the past in this event. Like there was this one where they had 4 wheels coming down and each one of them would pivot around on its own little axis, but the whole robot would stay perfectly straight. Lots of creative solutions, for sure. So that's called differential drive steering. You can see a lot of that. And then, of course, you've got the third motor, which is what operates the arm or the hook or whatever kind of attachment that you've put on your robot. There's a lot of ways to use the third motor for that, but pretty much the way it works out is you have to use 2 motors for steering and drive. There's really no easy way to get around that. So you've got 3 motors. The rules of the game are you cannot have a 4th motor no matter what, ever at all. So you got to use 3 motors. The third motor is useful for attachments. And there's a number of ways that you can get around the limitations of only having 1 extra motor, such as a ratchet or a multiplexer. And these things are kind of complicated. I have a little model to show you. Oh, a kid is playing with it. So I won't show you, but I'll show you my ratchet design. Hang on a sec. Ratchet design. Where is it? Here it is. It's funny. So with this ratchet design, what you've got is you have something that I'm rotating this back one clockwise, and the front one goes counterclockwise. Well, it depends on which way you're looking at it. If I rotate the other way, it actually keeps going that same direction. You see that? That's just a ratchet system. It'll always go the same direction because of that little ratchet in the middle. So you don't have to do it doing the same output. You can have them on 2 different outputs, meaning you can do 2 different things using 1 motor. And it's solutions like that, creative solutions like that, which make this event so interesting that people come up with these things. That's all for now. Back to the robot games, and we'll have more interviews shortly.